Okay, so today we are trying to focus on VPN implementation, IPsec VPN implementation. I
Okay.
hope you complete basic VPN video, UNC.
Yes. I complete this one since yesterday.
Okay. So now, if you remember basic VPN video, you can create a tunnel in between two branch office, right? For example, I have branch office A, I have branch office A and branch office B. So I can create a tunnel in between branch office.
Mm,
This is branch office A. This is branch office B.
B.
And to
Yes.
create tunnel, we can use crypto map concept. For example, this side we have LAN portion, for example, 192.168.10 dot network. This side we have 192.168.20.0/24. Now this portion we are using as a public side portion, as a ISP side portion to create
Mm,
VPN tunnel. To create VPN tunnel, we required source public IP and destination public IP. So this is your
okay.
public facing interface, this side, public facing interface. So from this branch office, you can configure default route towards ISP. From branch office to configure, you can configure default route towards ISP. This is ISP, Internet Service Provider.
Mm,
Now, here I'm using, for example, 10.1.12.1. Here we have 10.1.12. This side 10.1.23.1. And this is 10.1.23.2. So I can establish VPN tunnel, IPsec VPN tunnel with crypto map command. So if you remember our command syntax, what you can do, you can use a command crypto ISACMP, right? Let me show you command syntax
yes.
first.
I remember yesterday.
So I'm trying to configure on branch office A. So this is command syntax. Let me show you. This is command syntax. Now this is command syntax you can use on site A branch office. The first one, you can generate your session key, right? You can generate your session key. This is session key. This session key I'm trying to exchange with other branch office. Other branch office IP is 10.1.23. Now we can create our phase one tunnel. This is phase one tunnel. In phase one tunnel, we can use parameters, and you need to use same parameter on both branch office. For example, I'm using triple dash for encryption here, Diffie-Hellman group 2, hashing MD5, and authentication pre-share is a method. It means I'm using same session key on both branch office. So first we can generate session key. The next option, we can create our phase one tunnel. This is your phase one tunnel configuration. Phase one tunnel configuration. Next step, you can go with phase two tunnel configuration. This command is for phase two tunnel, phase two tunnel. To allow our traffic, we can create our interesting traffic. Which traffic you want to allow through VPN tunnel. For example, I want to allow 192.168.10.0. Okay, they can communicate to 192.168.20.0. So I can define interesting traffic. This is source IP here, 10.0. This is source IP, and this is destination network. Once you configure everything, your next task is to map all the configuration with each other. So we can create crypto map here. We can create crypto map, and this is crypto map name. CMap is crypto map name. In crypto map, we can call ACL. Please match address 101. This is ACL entry 101. And once ACL match, then set peer address 10.1.23.2. Set transform set we are using ABC. Now once you configure your crypto map, this crypto map you can apply on public facing interface. You can see clear?
Yeah.
Remember this task? So this is site to site VPN. This is site to site VPN through crypto map. This lab is called what? Site to site VPN implementation. Site to site VPN with crypto map. Crypto map. Crypto map. But now today we are trying to implement GRE tunnel concept. I'm trying to configure GRE tunnel. Why GRE tunnel? If I can establish my site-to-site VPN connectivity with crypto map concept, why I'm using GRE tunnel, MGRE tunnel, or DMVPN tunnel? So the problem with the crypto map, site-to-site VPN with the crypto map, the problem is what? You need to define your interesting traffic here. If you focus on this line, and you can see if you focus on this line, okay,
Yeah.
I'm talking about interesting traffic. If I have,
Access
for
list.
example, yes, yes,
Now, to specify the access list, I remember yesterday when I was following watching the video.
yes, you need to define interesting traffic, right? So the
Mm.
problem is what? You need to define interesting traffic. This is the issue. The issue is what? If I have, for example, this side 100 IP, 100 IP,
Hmm.
this side I have 100 IP. If I want to allow a specific IP, for example, here we have a specific IP 192.168.10.1, 10.2 can access 192.168.20. If I want to create interesting traffic entry, if I have 100 IP this side, 100 IP this side, so I need to create each entry in ACL rule. I'm not talking about subnet entry, okay? I'm talking about specific IP. Interesting traffic is what? I can use subnet or I can use specific IP, right?
Hmm.
So if I have 100 or 150 IP to this side or multiple subnet this side, multiple subnet this side, so I need to create source and destination network entry in ACL.
Okay.
100 ACL, for example, 100 ACL I want to create here. In 100 ACL rule, I can define source IP, destination IP, source IP, destination IP, source IP, destination IP. Same task you need to do on site B branch office. You can create 100 ACL entry, source IP, destination IP, source IP, destination IP. Clear the problem, clear the challenge, Juvency?
Yeah.
That's why I don't want to use crypto map concept for site to site VPN implementation. No, that's why I'm looking for GRE tunnel. Why GRE tunnel? GRE tunnel. Why it's a GRE tunnel? Let me tell you the example. GRE tunnel is required. For example, if I'm working in a branch office, okay, I have two branch office. Let's go with the example. I have two branch office. I have two branch office A and branch office B. So the real network is what? Both the branch office, they are connected with public IP. They are connected with public IP. What I can do? What I can do here, this is branch office A. This is branch office B. I will configure IP address 10.1.12. Here I have 10.1.12.2, 10.1.23.1. Here I have 10.1.23.2 public facing interface IP. So now in a real network, I can configure WAN interface. I can configure LAN interface. On site B branch office, I can configure WAN interface. I can configure LAN interface. Now in a real network, I can only configure default route towards ISP. Why? Because ISP
Yes.
is my unknown destination. So towards ISP, I will only configure default routing. Default routing. Why I'm creating default routing? To create a reachability. To create a reachability in between this source public IP to this destination public IP.
Destination.
And
Yeah.
with default routing, you have only connectivity with public IP. You don't have reachability. You don't have reachability. LAN network. Site A LAN network cannot communicate with site B LAN network. They cannot communicate. That's why we are looking for site to site VPN tunnel, and for site to site we already complete one lab in basic VPN with crypto map. With crypto map, I can configure site to site VPN tunnel here. But the problem with the crypto map, I need to configure interesting traffic. All the entry I need to configure in ACL. What traffic I want to allow through VPN tunnel, I need to create entry. And I don't want to do this. I don't want to create a lots of entry. That's why GRE is an option. That's why GRE is
Okay.
an option. What you can do, you can create a GRE tunnel here. What you can do in a real network, you can create a GRE tunnel. This is what here I'm creating what GRE tunnel. GRE tunnel.
GI.
GRE is what? GRE is a point to
GRE.
point tunnel. Generic,
Okay.
generic routing and encapsulation. So GRE is we are using for point to point connectivity. We have point to point connectivity, two branch office. I can create GRE tunnel here. This is my private tunnel. This is my private tunnel. I can create GRE tunnel and GRE tunnel. To create GRE tunnel, I require two information. What is source public IP? What is destination public IP? I require two information to create GRE tunnel. Source public IP and to create GRE tunnel. Yes, you need to know. You need to know what is source public IP, what is destination public IP. You need to know to create GRE tunnel. So I'm creating GRE tunnel here on site A branch office. And for this tunnel, I'm using a different subnet of IP 192.168.80.80.0 network. This is your private tunnel you can create. So you can use any IP address, no problem. So I'm using 192 onto this GRE tunnel. I'm using here 192.168.80.1. Here I'm creating GRE tunnel 192.168.80.2. So you will, once you create your GRE tunnel, you will feel like you have a direct cable connectivity from site A branch office to site B branch office. Clear my point? You have a direct cable connectivity.
Okay.
And with this cable connectivity, here you have 80.1 and this is directly connected interface. Logically, it's a directly connected interface. So on directly connected interface, I need to use same subnet of IP. So 80.2 here. Once you create your GRE
Hmm.
tunnel, so the benefit is what? Over this GRE tunnel, you can use any routing protocol. You will see.
Okay.
Over this GRE tunnel, you can configure any routing protocol to create a reachability. Let me create a design, okay, that you can get a clear picture. I have two branch office. Into this design R2, we are using as a service provider. So now what I'm doing, I'm trying to create a tunnel here, GRE tunnel. This is R2 into this design. R2 is acting as a internet service provider. This R1 is site A branch office. R2, sorry, R3 is a site B branch office. Let's configure IP address first. Basic configuration. Interface fast Ethernet 0/0. 10.1.12.1 mask. No shutdown. Interface loopback 1. 1.1.1 mask. Interface loopback 1. 192.168. 10.1 mask show IP interface brief. Let's configure default route for any known destination. 10.1.12.2 next hop IP. Let's go to R2. 10.1.12.2 no shutdown. Fast Ethernet 0/1. 23.1 mask. No shutdown. Host name I'm using as a ISP. Let's go to R3. This is site B branch office. We can give a name. Host name site B branch office. This is site A branch office. Let's go to R3. Interface fast Ethernet 0/1, 10.1.1.3.1, mask shutdown, interface loopback 0, 3.3.3.3, mask, interface loopback 1, 192, 168, 30.1. For any unknown destination, ISP is my gateway. UNC, can you hear me dear?
Yes.
Okay, so into this design, what we have, I have default route towards ISP. I have default route towards ISP. I have a default route towards ISP from both branch offices. You can verify your public to
Oh,
public IP reachability. So I'm trying to ping from this site A branch office to site B branch office, public IP. So I'm trying to verify my reachability. And just like a real scenario, I have two branch office, and in between site A and site B, I have reachability. I have
reachability.
reachability in between source public IP to destination public IP. But if you check here LAN to LAN connectivity, for example, 3.3.3.3, I'm trying to communicate with 1.1.1. LAN traffic is not traveling over this ISP connection. Clear now my point?
Mm.
And
Yeah.
I'm not looking for site-to-site VPN with crypto map concept because we know the problem, we know the challenge. I don't want to create a lots of interesting traffic entry. That's why I'm looking for GRE implementation. Today we'll
Okay.
discuss on GRE and MGRE. These two topics we can discuss. Let's focus on GRE. So we can create a GRE tunnel here. What I'm doing, I'm creating GRE tunnel, generic routing and encapsulation. Once you create a GRE tunnel, you will feel like you have a direct cable connectivity from this interface to this interface. You have a direct cable. This is called GRE tunnel. And for GRE tunnel, IP address I'm using for GRE tunnel, IP address I'm using 192.168.80.094, for example. Let's go to R1, how to create GRE tunnel. Command syntax is very simple. Interface tunnel command. Interface tunnel command, and you can create a lots of GRE tunnel. You see, you have a big number, right? You have a big number. So I'm creating my first tunnel, interface tunnel. To create
So,
GRE,
sorry, dear. I didn't catch you well. When you configure the TU interface TU. Ah, this is the tunnel. Interface tunnel. Okay. Now I understand.
clear now?
Yes, clear now.
Okay, now.
I was I want to understand the command. The command. Interface tunnel. Question mark. We have from 0 to this number.
Yes, it's like
Okay.
an interface number.
Yeah, interface number.
It's like
Yeah.
interface number.
Okay.
It's like a loopback. To create loopback, we have
Mm,
lots of option, right?
yes.
On this router, you can create a lots of tunnel interface. You have a big number,
Okay.
and I'm creating my tunnel one. I'm selecting a number what? One. On other side, you can use any tunnel interface number. Clear now, QNC?
Yes. Yeah.
It's like an interface, fast Ethernet 0/0, fast Ethernet 0/1, interface loopback 1, loopback 2, loopback 3. Same. Here we have tunnel interface. Interface tunnel and tunnel number I'm using 1.
Okay.
Now, into this tunnel, you can define, I told you to create GRE tunnel, we require two parameters. What is source public IP and what is destination public IP? So tunnel
Yeah.
source is a command, tunnel source. So what is tunnel source? Here we are using, if you talk about public IP, here we are using 10.1.1.1. 1.12.1, right? And on other branch office, here we are using 10.1.23.23.2. So let's go to site A branch office, tunnel source, 10.1.12.1. Tunnel destination, 10.1.23.2. So to create
Okay.
GRE tunnel, you require two parameters, source public IP, destination public
And
IP.
destination.
And now
Okay.
you can give a IP for this tunnel. IP address I'm using for this tunnel interface, 192.168.80.1. 80.1. Done. Done. GRE tunnel configuration. Only three steps is required. Only three
Okay.
steps is required. This is commands and text. Clear this commands and text?
Very
UNC?
clear. Yes, it's
This
clear.
is commands and text to create GRE tunnel on site A branch office. Let's go to site B branch office. Interface tunnel to tunnel source 10.1.23.2. Tunnel destination 10.1.12. Tunnel IP 192.168.80.2. Now you can verify show IP interface tunnel brief. I have tunnel 2. Now R1 show IP interface brief. I have tunnel here. And we have reachability. If you verify reachability with tunnel IP 80 dot on site B branch office, see, you have a reachability in between tunnel interface IP.
Um,
You have a reachability tunnel to tunnel
very,
IP. And if you
very
verify
interesting.
show interface tunnel 1 command, so you can see this tunnel is what?
Yeah, tunnel
GRE tunnel.
IP. Oh,
And to create this tunnel,
oh.
what is source IP and what destination IP you are using?
Uh, the public source IP and destinations.
Yes, you required source public IP and destination public IP to create our GRE tunnel. And you can see over this public network, you have a reachability with your tunnel IP, right? You can see.
Yes.
If you have a reachability with tunnel IP, now you can use any routing protocol. For example, here I'm using router EIGRP10. In protocol, you can only advertise your tunnel IP, tunnel IP, and you can advertise your LAN site network. So network 1.1.1.1 mask, network 192.168.10.0 wildcard mask, no auto summary. Let's go to site B branch office. I can use any dynamic routing protocol. Router EIGRP10 192.168.80.0 wildcard mask. Network 3.3.3. LAN network I can advertise into this protocol. Network 192.168.30.0 wildcard mask. Now you can see show IP, show no auto sum. You can see now you have a reachability. Show IP route. You can see you are receiving route from R3, right?
Yeah.
If you check here, you are receiving route information from
Mm,
R1 and you have reachability this time. See,
okay.
you have reachability this time. So this is
Yeah.
real network, Juvency, okay? Just like a
Yes.
real network, you have two branch office, and in between branch office, you have reachability in between source public IP and
Mm,
destination public IP. So you can create your tunnel. Once you establish your tunnel, if you have reachability in between tunnel interface IP, after that you can use any routing protocol. This time we have complete reachability. If you check, I can ping source. If I want to verify my connectivity with 30.1 with source 1.1.1, I have a reachability. But the problem with the GRE is what? If you right click and capture the signal, capture the packet in between site A and site B, the problem with the GRE is GRE will not provide you encryption. GRE will not provide
Okay.
you encryption. If I'm initiating my traffic, you can see any attacker can verify what traffic is traveling, right?
Okay.
So GRE will not provide you encryption. You can create GRE tunnel, but GRE will not provide you encryption. If I'm initiating my traffic, if I'm trying to ping 3.3.c, if anyone capture the packet, can verify, if any attacker will capture the packet, can verify this is source public IP, this is destination public IP, this is GRE header, this is packet header, see, source and destination IP and what protocol you are using, ICMP.
Okay.
So if anyone will capture the packet, yes, you have a tunnel, but the problem is GRE will not
You
provide
not
you
secure.
encryption. That's why we are using GRE plus IPsec. GRE plus IPsec. Now we
I
can
see.
create here tunnel.
Okay.
IPsec configuration. Remember our IPsec configuration? We can configure, we can
Two
configure,
phase.
we can configure session key, we can configure phase one, we can configure transform set.
Phase
Remember?
two. Oh yeah.
Let's go to site A branch office. Let's go to site A branch
And
office. And I'm trying to configure IPsec tunnel here.
okay.
IPsec tunnel. What is the command syntax? You can compare with notepad file. So wait. Now in our design, I'm here, site A branch office. So let's create our
Yeah.
session key, crypto Isaac MP key. Key. Key we are using CCIE address. This key I'm trying to exchange with 10 dot 1 dot 23 dot. Other branch office public facing interface IP. Now phase one tunnel, crypto
Okay.
Isaac MP policy. Authentication pre-share for encryption triple dash. For hashing MD5. For Diffie-Hellman group 2.
Hmm.
For phase two tunnel, I can configure transform set. So crypto IPsec transform set. Transform set name I'm using TS. ESP triple dash ESP MD5. Now I don't want to configure interesting traffic because this lab is not crypto map, right? This lab we are using with tunnel. So now here I don't want to configure interesting traffic. Interesting traffic is
Hmm.
not required. You can configure here IPsec profile, crypto IPsec profile. Profile name is what? Prof1. If you are doing your lab, side to side VPN lab with crypto map, so you can configure crypto map, and this crypto map you can apply on public facing interface, right?
Yes.
But if you are doing side to side VPN lab with tunnel interface, then you can create IPsec profile, crypto IPsec profile. Into this profile, you can call set transform set. And what is transform set name? TS. And this profile you can apply on tunnel interface. Tunnel interface. So how to apply this profile on tunnel interface? Command is tunnel protection IPsec profile. And what is profile name? Prof1. Done.
Fine. Okay.
You can see you are getting a message. Isaac EMP is on. Let's copy this configuration here. Let's copy this configuration. We can copy and we can paste on other branch office. So I'm trying to paste this configuration on other branch office. Now, let's change something into this configuration and we can paste on R3 router. So for R3 remote branch office is 10.1.12.1, right? So remote branch office
Yes.
is 10.1.12.1. So this is session key configuration, phase one tunnel configuration, phase two tunnel configuration, IPsec profile we can create. Into this profile, we can call our transform set. And this profile we can call on tunnel interface. But I think on R2, tunnel interface is not tunnel 1, tunnel 2. Okay. So here tunnel
Mm.
interface is what? Tunnel 2. You can copy this configuration and we can paste on R3. You can see you are getting a message what Isaac AMP is for. And again, you have EIGRP agencies. And now you can verify, show crypto Isaac AMP Shah. You have a tunnel now. You can verify here, show crypto Isaac AMP Shah. You have a tunnel now. You can verify phase two tunnel, show crypto IPsec Shah. IPsec Shah. What is Shah? Security Association, right? SHA is what?
Mm.
Security Association. So 12 packet encrypted and decrypted. Let's generate some traffic. And before generate some traffic, let's go to Wireshark. Wireshark. And I'm trying to generate some packet here. I'm trying to generate some packet from R1. You can see we are getting only ESP header information. We are getting only if anyone will capture the packet now. If anyone will capture the packet, can only verify what is source public IP, what is destination public IP, and after ESP, everything is encrypted. See, nothing is visible here. Clear this, Juvency?
Yes.
The packet format is what? In packet format, what you have source public IP, what you have destination public IP, what you have ESP protocol, ESP. So if any attacker will capture the packet, he can only verify what is source public IP, what is destination public IP, and ESP. After ESP, everything is what? Encrypted.
Mm.
Clear this lab?
Yeah, it's clear, but I need to make some exercise. It's not so
But
complex.
clear this point. The point is what? I don't want to configure a lots of ACL entry.
Mm.
That's why I'm using GRE tunnel concept. I
Jerry,
can create
yeah,
tunnel here, right?
yeah.
I can create tunnel. You can see now, you can see and you can check your configuration. No need to configure interesting traffic. See, we don't have ACL
Mm.
entry.
Mm.
I hope it's clear for you.
Yes, it's clear.
Okay.
It's clear.
Let's discuss
Very good.
MGRE and DMVPN tomorrow, Juvency. Okay.
Yes, but please send me the video, please,
This re-
because
this
I
recording
want
I'm
to.
sh- this recording I'm sharing in 15 minutes. Okay, dear.
Yes, yeah, it
Bye,
will
Juvency.
help me
Take
to do some exercise.
sure.
Bye. But one thing I want to ask about EVNG.
Mm-hmm.
I think it's very interesting to me to do some exercise on this one. Is it possible? Maybe tomorrow or after tomorrow to help
EVNG,
me to
you want to
install.
set up EVNG lab.
But with by example, this tiny session or tiny lesson, I cannot do some practice on EVNG.
Packet capture. You're talking about packet
No,
capture?
some lab, some exercise because I
All
want to
the all
install
the
on my
labs, all
computer.
the labs you can do in EVNG software. All the labs you can do.
Yes. Yeah, but my concern is if you can help me as you did last time for
Yes, I can help you to set up the lab.
genius.
I can help you set up the lab. Okay, tomorrow I can help you, no problem.
Okay, thank you.
Try to download
Because for
EVNG software.
sorry,
Try to download EVNG full pack. I think I already shared with you EVNG full pack software.
yes, you already shared to me. I have it.
Okay, so
But
yes,
for Genius 3, I installed by myself. Is okay. And I'm talking about the new laptop. Yeah, is okay. I don't know. Should I remove Genius 3 or I can keep it?
Genus 3 is a good option for routing lab, but yes, in future you need to go with the EVNG, okay? But
Yes.
Genus 3 is a good option for routing lab. Okay, it work fast.
Oh, okay.
Yes.
But I can have both on the same computer, or
Yes,
should
yes,
I remove one?
you can install both on same laptop. See, I have both software, EVNG and Genus 3.
Ah, okay. Okay. But I will use the same virtual machine. VMware no need to add another.
You want to add virtual machine in EVNG?
I need to add one virtual machine. Okay. Because now, what I can say, the my virtual my VMware workstation is
Mm-hmm.
already installed. I need to install another, or I can
No,
use
no,
the
no,
same
no. If you have VMware workstation, no problem. We can just import it.
import. Ah, okay.
We can just import it.
Okay. Thank you.
Let's continue our session tomorrow. Okay, Juancy? Tomorrow I can help you to set up the
Okay.
lab.
Okay. Okay.
Bye, dear. Take care.
Bye.